Good morning, or afternoon, or evening, depending on what time zone you're in. My name is Michael Klein. I am the software development tech lead with the repository development and administration team at Northwestern University Libraries. I'm here with Trey Pendragon from Princeton University Library and Edward Silverton from Nemesine in the UK, and Jonathan Hartzler from the University of Notre Dame also contributed to this presentation, but they were unavailable today, so I will be handling their slides and contributions to the best of my ability. A little bit of background. I'm not going to read everything here, but in 2016, Northwestern Central IT started taking steps to encourage people all over campus to build new applications and move their existing applications and infrastructure to Amazon Web Services. It's been a campus-wide push. We have a whole lot of support, and they provide us a lot of resources and consultants and everything that we've needed. Over the next 3 years, we managed to move several of our library applications into the cloud, some moving from the on-prem data center and some being built cloud native from the beginning, including our shared Samvera stack, Fedora, Solr, Zookeeper, with native database, Redis, and file system storage support. In doing so, we've learned a lot of things about cloud architecture that inform the way we design and build systems. First of all, services are better than servers. Availability is more important than straight uptime. All instances of servers are ephemeral. Anything can go down or be replaced at any time, so you shouldn't be depending on local storage, local disk storage, having stuff cached or existing on a specific instance. Local storage is an illusion, and never copy source data when you can stream that. And I'll get into that more in a couple slides from now. The idea of moving our IIIF services to the cloud came with some observations. IIIF access is bursty by nature. For those who don't know, IIIF is an image interoperability framework that specifies a common URL format for accessing image data over servers, among other things. But that's what the 2.1 image API version 2.1 focuses on. It lets you specify things like cropping, scaling, rotation, and color modification right there in the URL in a standard way. So if you're requesting images from a IIIF server, you know what the URL format is and how to manipulate the image you want right off the bat. Tile requests, which are what are used for things like Google Maps or any number of those zooming image viewers that you see that let you zoom from an overview into high detail, are at least an order of magnitude burstier than other full image requests because people pan around and zoom a lot, and it creates a whole lot of requests for smaller images. It's very hard to scale a server-based IIIF solution in a way that can handle your maximum demand or even your average demand without spending a lot of time sitting idle and wasting capacity and money. We started with the Cantaloupe image server, which is a great project. It is flexible, fast, and powerful. It's easy to deploy, but its configuration file is practically a programming language on its own. It has a whole lot of options, but getting the right ones for your needs can be tricky. It wants to copy source images from your storage and cache them locally in order to do its work. And it scales at the server level. So if you find that you are at your maximum capacity, you have to double that capacity in order to meet that demand. And sometimes that's too much, sometimes that's not enough. It can be hard to get it right. And lastly, it has a lot of great features, but we didn't really even need most of them. So we were putting a solution out there that was both bigger and smaller than what we needed. So as a proof of concept, I took a few days, 2 or 3 days, and decided to build a serverless IIIF server using Node.js. I wrote a module called IIIF processor that turns a IIIF URL path, that standardized crop, rotate, size, parameter path, into an image or an info.json result, which provides some information about the image and how it can be manipulated. A serverless IIIF Lambda function wrapper that mediates between the web service and the node module. I'll get into that a little more, but essentially a Lambda is what AWS calls the thing that Google calls cloud functions. Every cloud provider has their name for it, but it is a function that runs without requiring a server. All the server infrastructure is handled by the provider, and all you have to worry about is your function, its permissions, and how it interacts with the world around it. Amazon API Gateway is a service that takes web requests and converts them into various requests to other AWS resources or other internet resources based on various routing rules. I can't get into it too deeply in this talk, but there are plenty of examples available, and I'm happy to talk about it or any of this offline as well. But it converts the incoming web requests into AWS Lambda calls and returns the result to the client. Amazon Simple Storage Service, or S3, is object-based storage where we store the images that can be served up by the IIIF server. And lastly, the AWS Serverless App Repository, which isn't really part of our runtime environment, but it provides application versioning and packaging, and it also allows us to share the application in a way that can be deployed by us in new environments or by others and customized from there. Under the hood, our node implementation uses libvips, which is in the project's own description, a demand-driven, horizontally threaded image processing library. It's very fast and extremely lightweight, fits in very little memory, especially compared to image magic and graphics magic. It can perform more than 300 different image manipulation operations, though we only use a fraction of those. It supports a large number of image formats. And most importantly, for our purposes, it natively supports multi-resolution images and tiled images, the kind that have pre-computed subsections ready to go for the kind of tile servers that I was talking about earlier. We also use Sharp, which is a fast native Node.js wrapper for libvips. It makes libvips really easy to call and use from JavaScript. And in line with the stream rather than copy situation request, it supports seeking and streaming of image data without making a local copy. What this means is that we can tell Sharp what we want to do to the image and what size we want it to come out as, and then point it to where the image lives on the internet anywhere. In this case, it's an S3 storage bucket, and it will request the header of the image, look at the directory of the container format that the image is in, and download only the parts of the image it needs in order to satisfy the request. So you might have a multi-megabyte TIFF file with several different resolutions of the image embedded in it and a whole lot of tiles, but it will only grab the byte range or byte ranges that it needs in order to create the cropped, resized version that has been requested. And that makes things a lot faster and a lot simpler. And then deploying this application, once it's packaged up and sent to the serverless application repository, is a really simple task. The items I've highlighted in red are the only 3 required steps. You can fill in a new application name if you want to, or if you want to deploy multiple instances of it in your stack so that you don't have name collisions. You can customize the timeout if, in seconds that you expect things to respond in. But really all you need is the name of the bucket containing your source TIFFs. And you need to click a box that acknowledges that this deployment will create custom access privilege, a role with custom access privileges. And then you click deploy. And about a minute and a half later, you have an endpoint assigned by AWS Lambda or API Gateway, which serves as the base URL for your request, at which point you can start requesting tiles and images from your server, provided that they're correctly placed in that bucket. A little more on this later if we have time at the end, but it really is that simple to get up and running with a IIIF server. Since we deployed this is a graph of 3 different metrics over the past 2 weeks of use. We put out an announcement about 2.5 weeks ago of the availability of the Berkeley Folk Music Collection, Berkeley Folk Music Festival Collection in our digital collections service. And we've had a lot of traffic over the past couple weeks. These numbers are averaged over 5 minutes. So when you see that spike there, right here, that's 2,500 requests in 5 minutes. And this is a good example of how bursty and spiky activity can be. Our collection is not nearly as big as Princeton's, so I'm sure Trey will have some more impressive numbers to show us. I mean, we don't have as much in there yet, but we also have down here the number of concurrent executions per 5 minutes. And this is a measure of how well our system scales and then scales itself back, because with Lambda, you only pay per second or per fraction of a second when your function is actually running. So no requests, no money. We're only getting charged when things are running, which leads us to the average duration per call. You can see that even our spikiest time here has a response time of about 113 milliseconds, but 11 seconds. But for the most part, we are at about 5 to 10 millisecond response times. Something must have really gotten stuck right there on the 25th. The first or second institution to express an interest in using serverless IIIF was Ed Silverton from Nemesine and his client, the Royal Pavilion Museums in Brighton. They use a Strapi.io content management system to get their content into their site with custom CSV import of TIFF files into their S3 bucket. So they have an automated system that just moves stuff through. Their IIIF manifests, which are lists of images that go together, are served up by an API endpoint from that content management system. And they have serverless IIIF running the image tiles. Ed contributed a lot of the configuration code that allows us to deploy in different AWS regions, and helped a lot with the serverless application repository part. I had been using CloudFormation to get everything set up, and he really made it possible to make it reusable in that way. Less than 10 pounds a month running, including their cost to Heroku, the site hosting their Strapi instance, and has resulted in a fourfold increase in traffic for their close look blog and no ongoing DevOps overhead so far. So that's been pretty successful for them. Now I'm going to turn things over to Trey to talk about their experience.
Sure, thanks, Michael. So we moved over to, I hope everybody can hear me okay. We good?
You're good.
Great. All right. We moved over to serverless IIIF from Cockadoo-powered Cantaloupe, which we had actually just moved over from Loris. And the reason was we wanted to sort of look into what moving away from Cockadoo would look like, and we had seen some issues with traffic. We had put OpenJPEG behind Cantaloupe for our JP2s, and it was too slow. It would crash. People would send us email that said, "Hey, I can't view your image," and that wasn't any good. And we tried doing pyramidal TIFFs in Cantaloupe, but still sort of the same thing. It was way too easy to crash those servers. And even more than that, we have so many images that it was very often, we had just migrated to a new larger server, and we already knew that we were going to run out of space. And things would happen, like we'd have to clean up the cache, or just all of that sort of server management stuff was kind of a bummer. If you could hit the next slide for me. So we spun up serverless IIIF. All the promises are true. In fact, it is very easy to just get running, and you point it at a bucket and you shove a bunch of pyramidal TIFFs in there, and it works great. When we had first tried it, we started deploying things to production and started generating images, and we started getting messages that was like, my images aren't loading. So that's not good. So we started testing it with Siege, which is like you hammer it with a ton of requests and you see when it breaks. And we found that the lambdas would freeze up. We thought it was a concurrent execution problem, but it didn't turn out to be the case. And I may or may not have also broken Northwestern's instance while I was testing this. But we eventually found out that we used to dynamically figure out the width and the height via streaming the file out. And for whatever reason, that would freeze up the Lambda. So now we just store that in object metadata. And that's in core now and works great. A couple of other things I wanted to mention is we have some really big images. Our biggest scroll is like 260,000 pixels wide. So it took a little bit of testing to figure out how to scale the images so that they would come out fast and you'd still be able to zoom in deep enough. So our formula is sort of, if you're bigger than 15,000 pixels, cut it in half before you make a pyramidal TIFF out of it. It sounds arbitrary, and that's because it is, and is a result of a lot of testing. And is also required because Lambdas have a limit to the amount of data you can stream out, which hopefully we'll talk about a little later. We also added CloudFront caching so that we don't have to generate the tile every time. If an item has been requested a lot, it'll be in the cache. If you could move one forward, please. So today, our entire digital repository is based off of serverless IIIF. We generated pyramidal TIFFs instead of JP2s for everything. It took a few weeks. But all we did is we said, do you have a pyramidal TIFF yet? If not, point to the old image server. If you do, point to new serverless IIIF, and it worked pretty flawlessly, actually. Today we have 14 terabytes, 4.8 million images, serve about 5.7 million requests every month. And about 40% of those are really fast because they come out of the cache. I wanted to give a little bit of a cost information because with all this serverless stuff, it usually like starts out really cheap and then you end up sort of at your standardized scale. We spend about $370 a month on this. 250 of that is just storage. Like we found out that we put it in the intelligent tier and found out that most of it probably could have been in infrequent access. It's all scaled down to infrequent access, basically. And $73 of that is Lambda, 33 is CloudFront, 12 is API Gateway. Long story short, you're going to spend the most money just storing a bunch of images. But now we don't have to be afraid of running out of space. It never falls apart. We don't have to fix any sort of like caching stuff. We haven't touched it in months. And I can't break it with Siege, so that's great. One more benefit is we do use Datadog for our metrics. Datadog has some really lovely AWS Lambda metrics, so we can build some really cool dashboards that we look at fairly often. We just recently added things like how much data have you added in the given time frame and how many more images have you added. Turns out we've added a terabyte in the last month. It's been a big digitization month for us. But we are very happy right now and it's working great.
Thanks. I'm going to talk very briefly about Notre Dame in a moment, but I also want to point out, because I mentioned Ed's contributions, Trey and I paired quite a bit while they were bringing this up on working out some of the bottlenecks, both the dimension stuff, which was primarily their contribution, and also finding another flag that we had to set in the Lambda invocation to prevent it from waiting for the event loop to empty out before it returned information that was causing lockups. And so Trey's contributions were extremely valuable to the project. Notre Dame started a project in 2018 to implement IIIF. And like Northwestern, they have a campus central mandate to put as much as possible into AWS. They also went with Cantaloupe as the image server and discovered the same things that we did. And I won't go through them again, but they were almost exactly the same trajectory we had. They discovered serverless IIIF just as they were starting to talk about building the same thing. And they had instant success, stopped having crashes, their response times dropped, and they were able to scale up quite a bit. And just yesterday, they made a whole lot of improvements to the structure of the system and the maintainability of the project, and put in a pull request yesterday that I merged and released as version 2 of this, and their contributions have been really excellent. So I want to give them a shout out as well. This really has, this started out as my side project, kind of like single institution proof of concept, and everyone's really stepped up and made it much better. And that's what I just said. Current limitations and future work. I have a confession to make. We're not really running this project at Northwestern. We would love to be. Serverless IIIF, the repository itself, was an extracted minimal proof of concept version that I pulled out of our production IIIF server so that I could do it as a lightning talk at Open Repositories 2019. And that lightning talk generated a bunch of interest from other institutions and got us where we are now, but we are still on the much bigger, bulkier IIIF server that doesn't have all these improvements that other people have contributed. There is a known issue in our README about a 6 megabyte limit on the amount of data API gateway lambdas can return. I have already described a workaround for it, but just haven't implemented it yet, but it's something that is on the radar. I'd like to be able to read more stuff dynamically from the image itself instead of hard coding tile sizes at 512 square and computing scale factors based on kind of a dumb algorithm. Works for now, but it can be better. And for our needs, one of the pieces that we are using, that we have in our bigger system, it involves authentication and authorization subsystems. And I have some ideas on how to work that into this project, but that is also future work. And that is the end of the prepared part of this presentation. I think I have maybe a couple minutes for questions. If you have anything for me or for Trey, I'll do my best.
There is one question that I see from Jonathan Roachkin. The issues with height width calculated in advance are not in the Northwestern reusable code. So Princeton, where are those at that you had addressed?
So that actually is in core now.
Okay.
That Trey, yeah, submitted that in, and it's actually a pretty flexible, pluggable system. There are two aspects that are really easy to modify are how your dimensions are calculated and how your TIFFs are stored in your S3 bucket. Like serverless IIIF assumes that they're just in the root of the bucket with id.tiff, but you can alter that really easily to put, make them in pair trees or some other organizational system.
I just wanted to add that that's true, but it does mean that when you generate those and when you generate the pyramidals and put them in a bucket, you do have to store the width and the height in the metadata. If you aren't doing that, we did write a Lambda to go and do that after the fact. If anybody wants to get a hold of me, I'm happy to share that. Yes, in the metadata of the object in S3, Jonathan.
So the question, yeah, about that. Okay. There's another question from Simeon Warner. How much does this strategy lock you into AWS? And do you have any sense of how easy it would be to port this to another cloud provider?
My sense is it would be super easy, provided that that cloud provider had similar conceptual frameworks for how things work. I know Google Cloud Platform does have the right pieces to plug together. It would not take a whole lot of rewriting. I really don't think it would be much of a trick at all, especially given the code reorganization that Notre Dame submitted. That makes it, I think, a lot easier to work with.
Second question from Simeon. In the deployment, denial of service DOS becomes DO $, denial of dollars. Is there a concern about that, and what measures can you reasonably take to manage this risk while still scaling to meet reasonable bursts?
I don't really have a plan for that. I know that there are AWS does give you ways to throttle and firewall things based on source and other criteria. Trey, do you have an answer for that one?
Yeah, so CloudFront makes it moderately cheap, but also API Gateway does come with both throttling as well as like a web application firewall you can turn on. We don't use it right now and it hasn't been a problem, but if like AWS definitely has the tools and they're pretty simple to put into place if that's something you're worried about.
Another question. Are you using serverless to generate the tiles, or are you using another service?
We are creating pyramidal TIFFs, which are multi-resolution multi-resolution images in a single file with pre-computed tiles. You don't have to use that format. I mean, Sharp will try to perform the transformation you're requesting on any source image in a supported format. But if you don't have if you're not using a pyramidal format with some pre-computed tiles in it, you might run into performance issues. We haven't really tried it, but you can throw whatever image you want at it and it'll return you the right thing, maybe just not as efficiently.
All right.